Welcome to qnawire.
So we're doing chapter 18, problem 65 here. So it says, assuming a typical nitrogen or oxygen molecule is about 0.3 nanometers in diameter, what percent of the room you are sitting in is taken up by the volume of these molecules themselves? So we want to find the volume allotted per molecule for a room at 1 atmosphere, 23 degrees Celsius, because that's roughly room temperature. And we want to compare this to the volume of an actual molecule modeled by a cubical volume. Okay, so PV equals NKBT, our ideal gas law. We rearrange for V. We call this our allotted per molecule volume. So that's V over N, the total volume over the total number of molecules. And that's given as KBT over P. Now, the actual V molecule, if we model these as cubical volumes between each molecule on a cubic lattice, this is going to be roughly D cubed, with this D being what we have up there. So, if we want to find the percent of the room taken up by the volume of the molecules themselves, then we can take V of the molecule over the allotted for the entire room, right? Per molecule. So this is given now as D cubed over KBT times P. So we can plug all this in now. So if we're at 1 atmosphere, that's 1.013 times 10 to the 5th pascals. And now our D is 0.3 times 10 to the negative 9 meters. Cube that. Take that all over 1.38 times 10 to the negative 23 joules per Kelvin times 290 times 300 Kelvin. Okay, so this comes out to be roughly 6.6 times 10 to the negative 4. If we put that in percentages, we times it by 100. So 6.6 times 10 to the negative 4 times 100 is 0.066% or 0.07%. So a very small, very small amount of the room is actually being taken up by the molecules themselves, and most of the room is just space between them, which is probably what you could imagine.